Alright, so in this video we go over the first chapter in statistics, which is a brief introduction in which we will briefly cover some basic definitions. I mean, despite being basic, these definitions are very important when it comes to later on discuss other topics, uh, which has to do with the type of data that we deal with and categories and all that. So first of all, let's define what statistics is. Well, statistics is a collection of methods for planning experiments, obtaining data, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the data. So pretty much all this list of characteristics of what statistics is will correspond to basically a whole chapter about. Right, so now they mention here obtaining data. What's data? Data, there's a lot of kinds of data. So data are observations. That's pretty much what it is, observations. But in this case, there's many different kinds of data. Like, for example, we take measurements, look at genders, survey responses, etc. There's many ways to obtain data and to define kinds of data. Now, where is that data coming from? Well, we need to be very specific, very careful whether we are talking about data obtained from a population or from a sample. So let's define each. A population is the complete collection of all elements like scores, number of people, measurement, and so on. Many different examples of populations. In this case, we include all in the set. Those are to be studied. The collection is complete in the sense that it includes all the subjects included, as opposed to the sample. That is just a sub-collection from a population. In a sample, we just take a subset of the entire population. Census is called the collection of data from every number in the population. So when we don't take a sample, that is, we collect data from the entire population, we call it a census. Otherwise, it's only a sampling. Well, what about types of data? So for types of data, we have two types of data. Number one, parameter. And a parameter is a numerical measurement describing some characteristic of a population. Whereas a statistic is just a numerical measurement describing some characteristic of a sample. So you might want to highlight this. So parameter is to population, whereas statistic is to sample. Okay. So in the following example, the following statement. So for following statement, state whether the presents represent a parameter or a statistic. Well, when Lincoln was first elected for presidency, he received 39.82% of the 1,865,908 votes cast. All right. So what are we talking about here? Are we talking about a parameter or are we talking about a statistic? In this case, this is going to be a parameter. I'm going to put a letter P for parameter and an S for statistic. And in this case, because they're telling us of the million, almost 2 million votes cast. So in this case, if it's said otherwise, 39.82 of the sample of this number from a larger number, well, then we would be talking about a statistic. That would be a sample, but in this case, we're talking about the almost 2 million votes cast. So that's all of them. So that's why it's population. None of them are excluded. So population. I mean parameter. All right. Based on the 800 77 randomly selected surveyed executives, it was found that 45% of them would not hire someone with a typographical error on their job application. Well, so in this case, what are we going to talk about? Are we talking about population or statistics? Would you like to take a guess? All right. Well, if your guess is statistic, well, then you're right, because in this case, they're telling us that these are 877 randomly selected surveyed executives. If it said based on all the randomly, I mean, based on all the surveyed executives in the United States, for example, well, that'll be all the population of executive. But in this case, it's just a small sample of executives. The current Senate of the United States consists of 87 men and 13 women. Well, would you like to take a guess? Is this a parameter or is this a sample? All right. Well, in this case, if your guess is a parameter, that is correct, because in this case, they're telling us the current Senate. Right? That is all the people in the Senate, not just some sample of people in the Senate. Okay, let's look at more examples over here. Letter D, a sample of students is selected and the average mean or mean number of textbooks purchased this semester is 4.2. All right. Well, in this case, I think this one is pretty straightforward. This is a statistic because they're explicitly telling us a sample of students. If they said otherwise, all the students in college, in a given college, well, that'll be the entire population, and in that case, it would be a parameter. A sample of students is selected, and the average or mean amount of time waiting in line to buy textbooks is 0.65 hours. Again, this is a statistic because they're just dealing with a sample of students. In a study of all the 2,223 passengers aboard the Titanic, it was found that 706 survived when it sank. Well, in this case, is this a parameter or is this statistic? I would say it's parameter because in this case, they're telling us all passengers about the Titanic, aboard the Titanic. That is all. They're not telling us a sample of passengers. In this case, it's all the passengers. All right, so let's further define kinds of data. Well, so we have quantitative data and qualitative data. So either way you want to pronounce it, I guess it's fine. Well, quantitative data consists of numbers representing counts of or measurements. So, for example, like money or physical quantities. All right. And qualitative, or also known as categorical or attribute data, most commonly rather, we call that categorical data. That can be split into different categories, right? And are distinguished by some non-numerical characteristic like gender, colors, names, or sports names of the sports teams, well, that I guess falls in the category of names. Now, quantitative data, in this case, this kind of can be further described, can be split into further categories: discrete data and continuous or numerical data. Well, what's the difference between the two? Well, so discrete data results when the number of possible values is either a finite number or a countable number. That is, like 0, 1, 2, etc. In basically integers. So that's pretty much the key. Mostly, basically, integers. Alright, and continuous data results from the infinitely many possible values that correspond to some continuous scale that covers a range of value without gaps, interruptions, or jumps. Well, I mean, all these words are going to make more sense with the examples that are going to be just right here next. Alright, to determine whether the values are discrete or continuous. If it's discrete, I'm going to write a D. If it's continuous, I'm going to write a C. When a car is randomly selected, it is found to have a tire pressure of 30 psi. Well, in this case, this is going to be continuous because in this case, pressure cannot be only 30. Could be 30.1, 30.2, 30.001. In this case, we can have all decimals for measuring pressure. Okay. That should be a C over here, and not here. This is actually should be blank. So in a survey of 1,059 adults, it is found that 39% of them have guns in their homes, based on a Gallup poll. Well, in this case, this is discrete otherwise. Why is this discrete? Well, because in this case, we're talking about number of people. And when we talk about number of people, well, we can count them in the sense that we have two people, 5 people, 75 people. There's no such thing as, for example, 30 adults, 27, 29, etc. But there's no such thing as 30.1 adult, right? There's no such thing, or 30.2 adults, just like in this case, in the pressure case. Okay. Statistics student obtains a sample data and finds that the mean weight of cars in the sample is 3,126 pounds. Well, in this case, be careful, because even though they're giving you a really nice integer, yes, of course, that can make you think that it's a discrete quantity. However, this is continuous because weights can have decimals, as opposed to number of adults cannot have decimals. For number of adults, we need to have only integers. All right. So, for example, it could have been 3,126.5 or 3,126.01. Well, those decimals make them continuous. All right, so the number of eggs that hens lay. Well, in this case, discrete. Right, discrete. Well, can you count eggs? Well, we can count eggs. For example, 1 egg, 2 eggs, 3 eggs, and for example, in this case, there's no such thing as half an egg or 3/4 of an egg. No, it's an actual egg, not half an egg, not a seventh of an egg. No, it's a whole. It's counted as a one thing in this case. So you cannot add decimals or like 3.5 eggs, or like 3.47 eggs. So it's not possible to have something like that. As opposed to the amount of milk from cows, well, this is a continuous quantity because, well, of course, you can get milk from a cow and obtain 3 liters, right? But you can also have 3.01 liters or 3.02 liters. These are no longer integers. You can have all kinds of numericals, all kinds of numbers for volume in this case. All right, what about, let's move on to level of measurement of data. So that's the data can be further described based on the levels of measurement. For example, the 4 levels of measurement is the nominal, ordinal, interval, and ratio. So we're going to define each of them, because we need, when we use data, when we handle data in the different calculation that later on we are going to do, well, we need to be aware of what kind of data we are looking at. So it's important. It's an important factor when making a study like this. Okay, so the nominal level of measurement, the first one, well, it's pretty much characterized by names. We already talked about names, labels, categories, colors, and the data cannot be arranged in an ordering scheme. So this is very important. For example, if you take a sample of the different cars and you want to know how you want to know the different colors of them, well, yes, you can count how many red cars, how many blue cars, how many yellow cars. However, you cannot compare. You cannot say that yellow car is better than blue car. Even if you have more of them, all you're doing in this case is counting the numbers, just grouping by their color, but not compared, not arranged in an order scheme. As opposed to the ordinal level, in the ordinal level, you can actually arrange in the order, but in this case we need to be careful because the differences in their data values do not determine anything. We're going to look at examples of each, of course, so this make more sense. Interval level of measurement. Well, it's similar to the ordinal level. However, in this case, let's highlight data values cannot be determined or are meaningless. But in this case, difference between any two data values is meaningful. Like, for example, temperature. The difference. One place is hotter than the other one, or one place is colder than the other one. All right. And the most important thing, and you might want to pay special attention to this, is that there is no natural zero. For example, in the temperature case, when you say, 0 degrees, well, that's just a point of reference. That's just a point of reference. But the fact that the temperature is 0, it doesn't mean an absence of temperature. As opposed, for example, if you say 0 milliliters, okay, in that case, well, that's that means an absence of something, and in that case, that's what we call the ratio level of measurement. And in that case, it's very similar again to the interval level, but in this case, there is a natural 0. And again, the 0 indicates that none of the quantity is present, like the volume of a liquid, for example, or the number of people. If there's 0 people at a place, well, in this case, we're talking about we're at a ratio level because there's absence of people. If the temperature is 0 at that place where there's no people, that doesn't mean there's no temperature at all. The scale, it's 0 in whatever the scale we're talking about, but the temperature is there. It's just going to be cold, in fact. All right. Okay, so determine which of the 4 levels of measurement is most appropriate for each statement here. So we have nominal, ordinal, interval, ratio, like noir, like in French, noir. All right, heights of women basketball players in the WNBA. Well, in this case, what are we talking about? We're talking about ratio. Ratio, because in this case, if let's suppose a basketball player's height is 0. Well, if it's 0, that means there is no height at all. All right, which is best described by the ratio level of measurement. Ratings of fantastic, good, average, poor, or unacceptable for blind dates. Well, what are we going to have in this case? In this case, we are ordering from good to worst, or from best to worst, if you will, or actually good, fantastic to unacceptable. And of course, data values whether there's more average than fantastic. Well, if we make a difference, that it's really meaningless. What we're only doing is counting the number of ratings, but not finding any difference. So this is ordinal, because there's an order. It goes from unacceptable to poor, and then average, good, and in the end, whoa, fantastic. Current temperatures of the classrooms at your college. Well, we talk about temperature in this case, so that's the interval, because I mean, if the temperature is zero again, there is no natural zero in this case. Zero does not represent the absence of something. In fact, again, if the temperature is zero, it means it's cold. So there is a temperature. It's just zero in the scale, whatever scale, could be Celsius, Fahrenheit, or Kelvin. Consumer Reports magazine, the ratings of Best Buy, recommended, not recommended. Again, it's very similar to letter B. It's going from something bad to something good. So ordinal. Social Security numbers. Well, in this case, in this case, we're talking about numbers, and we need to be very careful. The one that it could be nominal or ordinal, and you want to be very, very careful. You might be thinking this is ordinal because Social Security numbers get bigger or smaller depending on the number, of course, right? However, in this case, we're gonna say this is nominal. Because if you find differences or if you try to compare Social Security numbers, there's really no difference between one or the other. So these are just numbers, like saying John, Mike, Mary. Those. Each of them have a Social Security number tied to it. The number of yes responses received when 1,250 drivers are asked if they have ever used a cell phone while driving. In this case, it's going to be, if you want to take a guess first, want to take a guess. If you guessed R for ratio is fine, that is correct, because what if from this sample, 0 drivers said that they have ever used a cell phone while driving? Well, that's the absence of people from that sample. In this case, none of these people sampled were using a phone. So in this case, it's absence of something. All right, let's look a little bit more. Zip codes. What about zip codes? So zip codes are very similar to Social Security numbers, because even though they're numbers, the fact that 91910 is smaller than 91921, well, it doesn't make a difference. It's just a zip code assigned to a certain place, but that doesn't make it bigger or better than the other one when comparing. So there's no way we can use the ordinal in this case. And then the distance between two cities. So what if what are we talking about in this case? Well, in this case, we're talking about the ratio, right? The ratio level of the ratio level, because in this case, the distance between two cities. Well, what if the cities are just next to each other? Just their distance is 0, right? I mean, depending, I know what you might be thinking. If you go from downtown to one of the cities to the other extreme of the other city, well, yes, you will be traveling between two cities a certain amount of miles. But I mean, in this case, if you are in the bound of one city and then you just basically walk to the other side of the city, well, you're in a different city. The distance is 0, and in this case, there is the fact that the distance is 0. It means no distance, all right, because you're just next to the new city. All right, collecting data. So how do we collect data? Well, there's different methods that we're going to consider here. And in this case, we're going to look at observational studies and experiments. Let's define all of them. So, in an observational study, all we do is observe and measure a specific characteristic, but we do not attempt to modify the subject being studied or to intervene in one way or another. As opposed to an experiment, we apply some treatment and then proceed to observe the effects on the subject based on in our intervention. All right, so let's look at some examples. Determine whether the description corresponds to observational or experiment. O for observational and E for experiment. So research is conducted to determine if there is a relation between brain cancer and cell phone use. So in this case, let's see what are we talking about. I'm gonna say observational, because in this case they're not telling whether the researcher is doing some input to determine if there is a relation between brain cancer and cell phone. So all they're doing is just observing a bunch of people that use a lot of their cell phone and determine whether they could develop brain cancer. 30 university students are divided in two groups. One group receives free tutoring in mathematics, the other doesn't. After one semester, scores on the final mathematical examinations are compared. In this case, this is going to be an experiment, because in this case, one group is it's actually intervened by offering tutoring to see the effect. Okay, so they're experimenting by tutoring the students. In a study of 449 children with a particular disease, the subjects were photographed daily. Well, interesting. So, is this going to be an experiment, or is this going to be an observational? So in this case, it's an observational, because they're not doing anything. They're not doing anything to the patients. All they're doing is observing how are the children changing over time, to see if there's physical changes due to that particular disease. In a particular study of 402 children with a particular disease, the subjects were given certain drugs to determine if the drugs had an effect on the disease. Well, in this case, the subjects were given certain drugs, so something is being manipulated in the research on the researchers' end. So in this case, this is an experiment. And last but not least, research is conducted to determine if there is a relation between heart arrhythmias and caffeine consumption. Well, in this case, it's not. They're not telling us that. They're not telling us whether there is some intervention here, or doing some treatment, right? So they're just observing people who drink a lot of coffee, and then if there is a relation to heart arrhythmia. So this is observational kind of study. All right, just to wrap up this first chapter. So in this case, types of sampling. So we are going to look at different ways to collect data. In some cases it's appropriate, some cases may not be appropriate. So depending on the type of study that you want to do, well, you want to look at the correct way to take a sample. For example, if you want to study, if you want to find out what's the best kind of food, for example, you're not going to go to a pizza place, because that's going to be in a way biased towards the people who eat pizza. So what you want to do instead is go to a more neutral place. I don't know, at a school or a mall or just in the streets. So you're not going to go to to an Italian restaurant, and they're going to say, oh, Italian food is going to be the best food. All right. So, well, we have a couple of sampling. Number one, random sample, and simple random sample. Well, so for example, random sample, these ones. So suppose I have this population, all right? Okay, in this case, the idea is that every single member right here has an equal chance of being selected if it is to choose from a population. All right. So, and in a simple random sample, in this case, well, we are going to have this population, which is divided into, so this population will be in a way, if you will, clustered. All right. In this case, we have one big population, and in this case, we have a possible number of 16 samples. The idea is that every possible sample has the same chance of being chosen. A sample from here, a sample from here, but in this case, for random sample, it's all the individuals in the population. Well, we can further describe other kinds of sampling, like systematic sampling rather. In this case, we select some starting point and then select every kth element in the population. As an example, well, suppose you want to make a sample, you want to make this systematic, and you want to ask a bunch of people whether they spend some money at a college cafeteria. But you don't want to ask all of them. You're going to stand outside of the cafe or somewhere maybe at the bus stop of the college, for example, and you are going to ask only the third person that goes out of classes, for example, to take the bus, or the fifth person, or the seventh person only, not just all of them at the same time. So what you're going to do, you are going to write down on your notes that you are sampling every 10th person or every 17th person. Convenient sampling, and it's typically the easiest one or the simplest to obtain good results. For example, and in this case, like an email, like an email, for example, when you want to determine whether they. So in this case, let's say you order pizza, and you want to know whether the pizza is good. You're not going to sample all the entire population. What you're going to do, for convenience, sample your customers, whether they are satisfied or unsatisfied or something. Stratified. Subdivide the population into at least 2 different subgroups or strata, so that subjects within the same subgroups share the same characteristics. Then draw a sample from each group, which is similar to the simple random sample. So you're going to subdivide the population into at least 2. Well, in this case, we have 16. Right? Yes, maybe I need to add more dots so it looks populated. All right. I guess that's enough. Maybe a little bit more. Yes. All right. And last but not least, cluster sampling. In this case, we divide the population area into sections or clusters, then randomly select some of those clusters. Very similar to the previous one. Okay, but in this case, you choose all members from those selected clusters, not just a few from each sample. Okay, so let's identify which type of sampling are we using here. Well, so A newspaper asks its reader to call in their opinion regarding their taste in reading well. So you want to approach people who read, right? Their taste in reading well, of course, in the newspapers, because if they're readers, they're going to read this question. So this is a very convenient way to obtain data. To estimate the percentage of defects in a recent manufacturing batch, a quality control at Ford selects every 16th truck that comes off the assembly line, starting with the 7th, until she obtains a sample of 90 trucks. Well, in this case, we're taking every case, like in this case, it's systematic sampling. To determine her blood pressure, Jean divides up her day into 3 parts: morning, afternoon, and evening. She then measures her blood pressures at 4 randomly selected times during each part of the day. In this case, notice they're doing different groups. Well, in this case, based on time, like morning, afternoon, and evening, and this is the stratified. So in this case, she's going to look at her pressure at different stages of the day. To determine customer opinion on their food quality, General Foods randomly selects 60 city blocks during a certain week and surveys all homes within the city blocks. Well, of course, they're clustering the different blocks, so cluster. And of course, this is all we have to say about this chapter. Again, it's very, very important to understand the kind of data that we are dealing with when it comes to do any kind of research. So it's the kind of data that we're dealing with and the type of sampling that we're doing. Are we doing an experiment? Are we doing an observational study? Well, it depends on the subject. So this is a good place to quit. I will see you in the next video.